From July 25th to July 7th of 2021, Western North America experienced an extraordinary heat wave that affected Northern California, Idaho, Western Nevada, Oregon, and Washington in the United States, as well as British Columbia, Alberta, Manitoba, the Northwest Territories, Saskatchewan, and the Yukon in Canada. Climate change, together with several meteorological factors, including an atmospheric river of moist air that originated in China, contributed to this once-in-a-thousand-year event. In this video, I will explain how the atmospheric river contributed to this record-breaking heat event. This image shows the temperature anomalies that occurred on June 27, 2021, when the heat wave peaked in the northwestern United States and southwestern Canada. In the darkest red areas on the map, temperatures reached as much as 15 degrees centigrade or 27 degrees Fahrenheit above the average temperatures recorded for these locations during the previous 6 years. On this day, the temperature reached 49.6 degrees centigrade or 121.3 degrees Fahrenheit at the town of Lytton, British Columbia, setting an all-time record for Canada. In addition, high temperature records were set in numerous other locations in Canada and the United States. There were numerous costly consequences of this extreme heat wave, including more than 1,000 heat-related deaths. The majority of these were in Canada, owing to the lack of air conditioning. Energy consumption soared as air conditioning strained to keep up. The extreme heat buckled sidewalks and roadways, distorted railroad tracks, and caused bridges to be closed. The extreme heat also damaged crops in parts of Canada and the United States. Many businesses had to shut down during the extreme heat to keep their workers safe, and several wildfires occurred in the region, including one that destroyed the town of Lytton the day after it set a heat record. In some locations, the excessive heat caused glaciers to melt more rapidly than normal, leading to flash flooding. Also, wildlife and fisheries suffered losses from the high temperatures. Normally, we associate atmospheric rivers, narrow bands of warm moist air from the tropics, with heavy rainstorms. But in this case, a heat dome had formed over the Pacific Northwest. A heat dome is a weather phenomenon consisting of extreme heat that is caused when the atmosphere traps hot air as if it's bounded by a lid or a cap. These heat domes happen when strong high-pressure atmospheric conditions remain stationary for an unusual amount of time. They prevent convection and precipitation and keep the hot air trapped within a region. Heat domes also are typically associated with minimal cloud cover and clear skies. This allows the unhindered penetration of solar radiation to the Earth's surface, intensifying the overall temperature. The intense solar radiation reaching the Earth's surface, along with high pressure aloft, prevented cloud formation and precipitation, so the thermal energy being brought in by this atmospheric river just added to the surface temperature increases. Note that without the presence of a heat dome, the atmospheric river that hit the Pacific Northwest would have caused major precipitation. Surface warming still would have occurred, but it would only have been about 5 degrees centigrade compared to the 15 degrees centigrade that took place with the heat dome in place, according to research done by Yale University professor Juan Lora and his graduate student Serena Schultz that was published in the journal Nature in 2024. To summarize, atmospheric rivers are narrow bands of warm, moisture-laden air that originate in the tropics and carry prodigious amounts of moisture to the mid and high latitudes in both the northern and southern hemispheres. Typically, there are between 6 and 10 of these atmospheric rivers active in the atmosphere at any given time. The moisture content of these atmospheric rivers is comparable to that of actual physical rivers. Normally, when an atmospheric river encounters a landmass, it drops its moisture in the form of heavy precipitation that can lead to dangerous flooding. Recent research by Juan Lora and Serena Schultz shows that these atmospheric rivers contribute about 5 degrees centigrade of additional surface warming in their vicinity. However, if the atmospheric river encounters a stationary, high-pressure atmospheric heat dome, it can raise surface temperatures by up to 15 degrees centigrade, leading to extremely dangerous heat waves that can last for several days. Thanks for watching. I hope you have found this discussion of atmospheric rivers interesting and informative. If you have any questions or comments, please post them in the comments section of the video, and I will do my best to respond. Also, please take some time to view some of my other climate-related videos. And if you are not already a subscriber to my YouTube channel, please be sure to hit that subscribe button.